Hello friends, welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge series, where we are solving the daily LeetCode challenge problem with end to end. We are also live coding the problem so that you understand the approach as well as how to come up with the solution. Let us take a look at today's problem statement. Title says maximize area of square hole in a grid. You are given two integers n and m and two integer arrays h bars and v bars. The grid has n plus 2 horizontal and m plus 2 vertical lines, creating one by one unit cells. The bars are indexed starting from 1. You can remove some of the bars in h bars from horizontal bars and some of the bars in v bars, that is vertical bars. Note that other bars are fixed and cannot be removed. Okay, we have to return integer denoting maximum area of a square shaped hole. Square shaped. In a grid after removing some bars, possibly none. Okay, so the problem statement mentions that we have given n by m cross grid where each cell is of size 1 by 1 square and we want to maximize the area of square shaped hole. And in order to make the maximum square shaped hole, we can remove some bars from H bars and some bars from V bars. So we are given this H bars and V bars and we can remove some of the bars and we have to come up with maximum possible area of a square. There is no constraint on removing minimum number of bars. We can remove any number of bars. Okay, so as you can clearly see, here n is 2, m is 1. It means it is total number of the total number of the grid has n plus 2 horizontal and m plus 2 vertical bars. So 2 plus 2, 4 horizontal. 1, 2, 3, 4. And m is 1. So 1 plus 2 is 3. 1, 2, 3. 3 vertical bars and 4 horizontal bars. So we have to remove some horizontal and some vertical to obtain the maximum square. We have to choose the bars from these places only. We cannot remove all other. We have to choose out of these only to come up with maximum. For example, in this example, if you can see, the one way to get maximum square shaped hole is by removing horizontal bar 2 and vertical 2. If you remove the second vertical horizontal bar and also the second vertical bar, these four individual small squares can be combined and total sum is 1 plus 1 plus 1 plus 1, which is nothing but 4. So we return 4. Okay. In this case, we have this grid and H bars and V bars are 2, 2. So if we remove the second horizontal and vertical, we get maximum area of 4. So that is our answer. Okay. Now, if you carefully observe in this case, we are having H bars of 2, 3 and V bars of 2, 4. Okay, so 2, 3 H bars. 2, this 2 and this 3. And verticals is this 2 and this 4. If you carefully remember in V bars, there is no description of 3. It means the third bar is constant. We can remove either 2 or 4. If you remove 2, the maximum area that the width of a square that is obtained is 2. And if we check how many horizontal bars can be removed, we can remove 2 and 3. If you remove 2 and 3, the maximum cells that can be combined together are 3. 1, 2, 3. But since 3 is fixed, we can only get maximum of 2 here. So, and in order to obtain a square, we have to either choose this or this, which computes to the area of 4. So this is also one of the maximum area. But if you can see in the demonstrated example, they have removed third horizontal bar and fourth vertical bar. Even if we remove the third horizontal, these two are combined, and when this one is removed, these two are combined. Okay, now I hope the problem statement is clear. Let us try to break down this to reach to our solution. how should we approach? Now, whenever such problem arises, you have to think what are the hints given. It mentions each individual unit cell is one by one. Okay, each unit cell is one by one. Apart from that, we have to remove some bars. Okay, we have to remove some bars. Okay, and we have to come up with maximum area of square shaped hole. Okay, carefully observe, we have to come up with square shaped hole. It should be a square shape, not a rectangle. So this provides us with a very good hint. Each individual cell is one by one. That means there are all horizontal and vertical rows, and out of that we have to form a square. In order to form a square, we cannot get more area than one by just removing the horizontal lines. We have to remove some vertical lines as well. Then only we can get a maximal square apart from one. The current minimum or maximum is one. Unless and until we remove some element, some horizontal as well as vertical columns, we cannot obtain a larger area than one. I hope that is clear. Now, if this is the case, I want to remove both. Right? My answer cannot accommodate by just removing the horizontal lines. Okay, in that case, what next thing that that should come to my mind is, if I want maximum area to obtain the square, can I only consider the continuous elements? Because let's say in this example, in yeah, which one? Yeah, in this example, if you carefully observe, vertical bars are 2 comma 4, 2 and 4. The third one is constant fixed. So at max, we can either consider this area between 3 to 5 or between this 1 to 3. Since this is a constraint, I need to consider the available to the left or right. I think this helps me with one hint of considering only the continuous elements in V bar as well as H bar, and whatever the minimum of these two, because in this case the horizontal bars were 2 comma 3. So if I remove 2 3, my max width of a square of a length is nothing but 3. But my since 3 is a constant vertical line, I had a constant of choosing these two or these two. That's the reason my answer became minimum of 3 comma 2, which is 2. This becomes the side in this case. Okay. Okay. Now with this, I know that I need to find continuous elements in both arrays. Okay. That's what I need to do. I need to find the continuous and multiply it with continuous elements, find the minimum and multiply. That's the answer. But in order to find the continuous, I need to ensure the given H bars and V bars are increasing order. Is it mentioned in the constraint? No, it is never all. It mentioned that H bars and V bars are distinct, but the order is increasing. It is not mentioned. So what we can do, we will first sort it first. So we will, now the algorithm becomes, we will sort it out, then we will find continuous elements, then find the we will find the minimum and return answer at the end. Okay, so this is our answer. Let us try to implement this. So in order to find the minimum, we want to find continuous elements. So what's the maximum continuous elements in H and Y? Let me declare two. Int max H, int max V. Okay. If you carefully see, what's the minimum or starting answer that I have one? I already have one, right? So I can start from one. Default is one. Now I can have a look on H bars initially. I plus plus, and here I will try to find if my current h bar is exactly equals to my previous plus 1. It should be strictly increasing. If this needs to be strict, I am accessing I minus 1, so I should start from 1. Okay. If it is exactly increasing, I need to increase the count. You might ask, where is the count? I will declare a count here. What is the count? Initially assigned to 1. Why 1? Because each element would consider to be the starting point. So it's 1. Else, if there is no increasing element, I can simply assign count equals to 0. Okay. Now, the same logic, I need to replicate it for v bars. So I start from 1, v bars dot size plus plus. If my v bars of exactly equals to v bars of previous plus 1, then I increase the count. So I need to reset the count here. It should be 1. I increase the count, and if condition not matching, I update. And after updating the count in each loop, I need to update this max h. So max h equals to max h comma count, isn't it? And similarly, max v equals to max v comma count. Okay. Now I am updating this. Now you might ask, what is the length of square? Once we have this, what is the length of square? Is it minimum of max h and max v directly? No, it cannot be just the minimum, because if you carefully observe, if I just remove one line, I'm able to get two squares in vertical direction, in horizontal direction. If I remove one, I get two access to two. So my length becomes plus one, whatever the minimum, I increase it by one. Okay. And finally, in order to return the answer, I simply square the length, because area of square is equals to length cross length, and I return it. Okay. Let's try to run this. I missed this semicolon here. Is there any other mistake? Don't think so. Let's run and check. Yeah, sample test cases are passing. Let us try to submit this now. Okay, my one test case is passing. Let's run for this test case. So whenever there is mistake, right? So there is always a room for learning. Let's try to debug. So we have N3 and 2 MS2. We have 3 to 4, and vertical bars is 3 2. So the increasing is okay. Sorry guys, I think one mistake is this is not sorted, right? And I mentioned that first step is of sorting. So I missed that critical stage. Uh, Excuse me for that. I need to sort the given input hpass dot, and similarly I will sort the v bars. Yeah, now I'll try to run this. Yeah, it's passing. Let me submit this. Okay, one more test case is wrong. Let us try to run this. What's the output? Here N4 5 3 2 4. It means 2 3 4 5 all are continuous. Okay. But here, what's the continuous? 6, 33, 34. So we are only getting three here and 3 here. So I should choose max of. Okay, let me check what the value of max h and max y. That's how we will be able to debug this for possible issue. Okay. For this, if you can see, the max v is coming as only 1. It should not have been. Max v, we have sorted it. So this sort internally uses the intra sort. Okay. And v bars, we are iterating on v bars. And if the current v bar is exactly equals to previous plus 1, we increase the count is reset here, and max v is equals to max v initially it's assigned to 1, and minimum of that, minimum of 1 plus 1 is 2. How is max v coming as 1? Max v should be 33 and 34, right? It should be initially assigned to 1. Oh, okay, my bad. Whenever I am resetting it, it should be updated to 1 because my starting is 1. The current element, which is the incorrect one, it should be 1. Apologies for the error. Now it should be fine. Yeah, let me submit this. And yeah, the solution is accepted. Now let us quickly discuss about the time and space complexity. So in order to find the time complexity, let us see what are we are doing. We are sorting. So as I mentioned, this sort internally uses the intra sort. So it basically goes for h log h. Okay. So this goes h log h. Similarly, this goes v log h, v log v, because the sorting takes n log n, and then we are iterating on h again, o of h, and similarly o of v again. So maximum is nothing but complexity is h log h plus v log v. Apart from the space complexity, we are not using any extra space for our use case. This sort might be using some internal recursion. So whatever it be, that's the only space. So it should be O of 1. Okay. I hope the problem statement, the method to approach towards the solution when a problem statement is given to us is clear. And I hope you also are aware of you also got to understand and learn a little bit more about the implementation part. So if you really like, if you're still watching and like the video, please give it a like. And if you do have any queries or doubts, please do let me know in the comments. And if you're new to the channel, please consider subscribing it. Thank you so much.